Welcome back to our Huawei eLearning course SDN Architecture and Ecosystem. In the fourth chapter, we will talk about SDN community development and history. First, we have a look at relevant standardization organizations for SDN. Probably the most relevant organizations if talking about SDN is ONF. ONF, Open Network Foundation, is a user-driven organization dedicated to the promotion and adoption of SDN. The major focus of ONF is to provide open standards for SDN. It is one of the most active organizations in promoting SDN concept. Open Flow standard is the main development coming out of the ONF. The Open Flow standard is the first vendor-neutral standardized communication interface defined between the control layer and the forwarding layer in SDN architecture. In this slide you can see the different versions of the Open Flow standard with some features for each release. The current version of Open Flow standard is version 1.5.1. The other important standardization organization for SDN is IETF, Internet Engineering Task Force. IETF represents a large and open international community of network designers, operators and vendors concerned with the evolution of the Internet architecture. IETF is open to any interested individual. According to IETF, the traditional network equipment providers need to build their own SDN architecture, because under the terms of IETF, Open Flow will clearly favor the chip maker industry with companies like Broadcom, etc., in comparison to network equipment manufacturers. These network equipment manufacturers are considered to be the biggest losers in this competition. So IETF stands more on the side of network vendors. Two more organizations on the field of SDN standardization, ITU-T, the International Telecommunication Union Sector for Telecommunication Standardization. ITU-T also started working on SDN relevant research and standardization. ITU-T has also standardized by partnering with ONF SDN environments that applied for carrier networks. And ETSI, the European Telecommunications Standards Institute. ETSI is an independent non-profit organization which represents mainly operators, BT, Telefonica, AT&T, Verizon, German Telecom, but also vendors like Intel or HP. ETSI has been mainly involved with network function virtualization, NFV standardization. Let's talk about open and community-driven initiatives. First, about the Open Daylight Project, ODL. The Open Daylight Project is a collaborative open source project hosted by the Linux Foundation. The goal of this project is to accelerate the adoption of SDN and to create a solid foundation for NFV based on a common software platform. Open Daylight is open to anyone, including end users and customers. According to Open Daylight, the southbound interface is not just based on Open Flow, it also adopts other interface protocols such as BGP, PCEP, OVS-DB, etc. and it exposes an open northbound interface which is used by applications. How is the SDN's view now in Open Daylight project? Well, SDN is considered to be a new approach to separate control and data plane with a centralized control plane. But as well, ODL supports a hybrid approach where the hardware may contain an open platform to communicate with a new external control plane on the controller. Southbound interface supports multiple protocols such as OpenFlow, PCEP, BGP, etc. Northbound interface support protocols like Young modeled NetConf protocol. This slide shows the major objectives of ODL. First objective, code. ODL is trying to create a robust and extensible open source code which needs to cover the major common components required to build an SDN solution. Second objective, acceptance. ODL is also trying to get a broad industry acceptance from vendors and users by using the ODL code directly or through vendor products or as part of commercial products. And third, community. ODL is trying to create a thriving and growing technical community, contributing to the code base, using the code in commercial products and adding value around that. On this slide, you see some members of the Open Daylight project. If you consider that the start of this project was in 2013, then you see that this project is getting some real good member support by really big companies. Of course, also Huawei is a member of the ODL community. Here we see the Open Daylight framework. The ODL controller is pure software, and as a Java virtual machine, it can run on any operating system as long as it supports Java. The ODL controller platform is designed as a highly modular and plug-in based middleware that serves various network applications in a variety of use cases. Each layer of the controller architecture performs specific tasks and hence aids in modularity, while the northbound API layer addresses all the REST-based application needs. The service abstraction layer, SAL, takes care of abstracting the southbound protocol specifics from the network service functions of the controller. The controller acts, as I already said, like a middleware in the ODL ecosystem. It is the framework that glues together the applications requiring service of the network devices and the protocols that talk to the network devices for extracting a service. The controller allows the applications to be agnostic about the network device specifications, thereby allowing the application developers to concentrate on the development of application functionality rather than writing device-specific drivers. This slide shows how an example of an ODL controller architecture may look like. The first software code release for the ODL controller was called Hydrogen. The second code release was called Helium. The third code release for ODL controller was called Lithium, which is shown on this slide. You can see the network orchestration layer, then the control platform services and applications in green color, then the southbound interface in blue color, and the data plane elements in gray color. Users now can directly download the software from the Open Daylight webpage to compose their own service architecture. Just allow me one short remark. The latest software release of ODL is called Beryllium, but it's not part of this presentation. Finally, let's talk about ONOS, which is the Open Networking Operating System. ONOS was introduced in 2014 by ON Lab. ON Lab, Open Networking Lab, is a non-profit organization founded by SDN inventors and leaders from the universities of Stanford and Berkeley to promote an open source community for developing tools and platforms to realize the full potential of SDN. ONOS requirements are from carriers and they are targeting at carrier networks. One major feature of the ONOS approach is its distributed controller platform, which provides scalability, high availability and performance to bring carrier-grade features to the SDN controller plane. The ability of ONOS to run as a cluster brings web-style agility to the SDN controller plane. And of course, ONOS is based on an open platform to avoid the risk of vendor login for the carrier. Here is a list of memberships of ONOS. They differentiate between partners and collaborators. The honors community is including some leading service providers, vendors, and a large group of collaborating organizations. Huawei was one of the 9 honors founding members and still plays a key role in the honors community. This slide provides a comparison between operator network and data center. So you can see that operator networks are much more complex than data center networks, referring to the network scale or the network architecture or the services or the network protocols or the device types. Due to these specific requirements for operator networks, the owner's architecture focuses more on high availability, on scale out, and on performance, as well as on a powerful abstraction for the northbound and the southbound interface. So the honors layer model provides a distributed core which is deployed as a service on a cluster of servers, and the same honors software runs on each server. Northbound abstraction APIs, which is including network graph and application intents to ease development of control management and configuration services. There are 2 powerful northbound abstractions: the application intent framework, which is shown on this slide, and the global network view. The application intent framework allows an application to request a service from the network without having to know details of how the service will be performed. Southbound abstraction APIs, honors is supporting multiple southbound protocols. It enables pluggable southbound protocols for controlling both OpenFlow and legacy devices. The southbound abstraction insulates the core of honors from the details of different devices and protocols. The southbound core API is a key enabler for migration from legacy devices to OpenFlow-based white boxes. This figure shows a visual inventory of the various honors subsystems. The ones with the gray outline represents features in progress during the appearance of this slide. There are many features of resources supported for operator networks in honors: multi-layer SDN control of packet optical core, layer 2 forwarding or layer 3, standardized southbound interface and flexible plugins, multi-layer network resource management, network performance statistics and fault management, support of interoperation between non-SDN networks and SDN networks during SDN migration from traditional networks, and so on. This slide shall highlight the differences between the network approaches from ODL and from honors. The major difference between the two is that ODL focus on bringing legacy networks, BGP, SNMP, and so on, and new networks, OpenFlow and SDN together, whereas honors focuses on the performance aspects and on the clustering to increase the availability and scalability. Honors focuses more on carrier-grade networks, and therefore more telcos are involved in their projects. ODL has more vendor support like Cisco, Juniper, NEC, and others, and it focuses more on data centers. Now we are at the end of this e-learning course, SDN Architecture and Ecosystem. Let's do a very short summary. Software-defined networking SDN is a very new network architecture that might change the whole telco industries. Let me just emphasize 2 major aspects of SDN. SDN will separate the control plane from the forwarding plane, and SDN will also need a new hardware device to centrally manage the forwarding devices. This will be the SDN controller. Open northbound and southbound interfaces will allow network control to be directly programmed at the controller. So this will provide a higher level of orchestration and programmability for future networks. Thank you for watching.